Hi, future doctors. Welcome to the next class. In this class, we'll discuss about equilibrium position, equilibrium or rest when different forces are acting. How the object will be at rest position. So let us assume if we are taking any object on horizontal surface, mass m is going to be placed. How the gravitational force will be acting, we said downwards. So to balance this, equal and opposite reactant force will call normal reaction. Whenever this object is at rest position, normal reaction is going to be equal to mg. N is equal to mg. Now, how many number of forces are acting on this object means two forces are acting, reactant force and gravitational force. Now, on this, if you apply some amount of force right side, if this plane is smooth horizontal plane. If you apply some amount of force right side, in which direction it is going to move means towards right side. Then how much force is going to act? F equal to, if it is moving with a acceleration, F is equal to ma. Then what is the acceleration of the object means? A is equal to F by m. Correct? But here we are discussing equilibrium or rest position. Therefore, object is at rest position when different forces are acting. So let us assume we are taking mass of the object is 5 kg. Right side if we are applying 10 newtons force. What is the acceleration? 10 by 5, 2 meter per second square. Now right side if you are applying 10 newtons force to keep the object at rest position, left side how much you have to apply means left side also you have to apply equal and opposite force, that is going to be 10 newtons. Next time, if same object is suspended by string, so within this string what will be developed, we said weight is going to, gravitational force is acting downwards. To balance this, tensile force is going to act in upward direction within this string. So at equilibrium position, T is going to be mg. So like this we are going to write. Next, I am taking mass of an object is m. Always its gravitational force will act downwards. Reactant force will act upwards. Unless and until it is not moving in vertical direction, both normal reaction and gravitational forces are equal. Blindly we can take that unless and until it is not moving in vertical direction. Now I am applying force in this direction. Yeah. In this direction means by making some angle theta. Now what is the acceleration of this object developed? We have to resolve this one into two components. One is f cos theta, another one is going to be f sin theta. Correct? Now, right side how much force is acting? F cos theta. To balance this, left side also you have to act same amount of force. Means to keep this object at rest position or equilibrium condition, you have to apply same force F cos theta. Let us assume if you are not applying F cos theta on smooth plane, all these are smooth planes only we are discussing. So F cos theta force if you are applying means what is the acceleration? The acceleration force F by m. Therefore, in place of this F, we can write F cos theta by m we can write. Now, at equilibrium condition, see upwards how many forces are acting here? F sin theta, n. Therefore, n plus F sin theta equal to mg. Isn't it? This is at equilibrium position. So, blindly you can remember at equilibrium position, upward forces equal to downward force. downward force. Like that, rightward force equal to leftward. So left side, right side, how many forces are acting? You have to equate. Then you will be getting equilibrium position. Next is object suspended by strings. Mainly this one only is important whenever two strings are going to be taken place. This is an object of mass m. Now within this, one tensile force will develop T1. So within this, another tensile force is going to be developed T2. Now see here, gravitational force is going to act downwards. They will give this theta 1. They will give this theta 2. The problem also will do, no problem. Now, at equilibrium position, how the forces are going to be resolved. So if you are taking T1, so this is one component, this is one component. This theta 1 should be equal to this theta. Isn't it? In mathematics, you will be getting this. How the angles are going to be equal. Same like this, theta. So this is going to be T1 cos theta. This is T1 sin theta 1. Already we said in basics, resolution of a vector, we said basics of NEET in first playlist. Theta 1 is basing, which side is basing theta 1? That side should be cos theta. Which is not having theta here, that should be sin theta. Now, in this case, see, T2 will be acting like this. Now, this is going to be theta 2. Therefore, T2 cos theta 2. Here, T2 sin theta 2. Now, see, right side, how many forces are acting? Right side, only one force. T2 cos theta 2 should be equal to left side T1 cos theta 1. Next, another one. Upward, how many forces are there here? T1 sin theta 1. T1 sin theta 1 plus T2 sin theta 2 equal to m. So this is at equilibrium position. We have to take upward forces, downward forces. Next, so they will take three forces in vector notation. Let us assume F1, which is making theta 1, F2, which is making theta 2. Another force is going to be, let us assume F3. Total three forces. So, if object is at equilibrium position, how we are going to write these forces? Now, F1 can be resolved into two forms. F1 cos theta 1, which is basing theta, that should be theta 1. This is F1 sin theta 1. Next term, this is going to be F2 cos theta 2. This is going to be F2 sin theta 2. You cannot resolve F3 because it is only along one axis. Now, at equilibrium condition, downward forces, upward forces, rightward forces, leftward forces. Rightwards here, F1 cos theta is equal to F2 cos theta 2. So they will take equation number 1. Next time, second equation, upward forces, F2 sin theta 2 plus F1 sin theta 1 should be equal to F3. Like this, we are going to take at equilibrium position. So, just if you are taking like this, your problems are going to become easy. So, this is about equilibrium position. Next, if you want to see any simple problem, we will do one problem on this string type. So, this is going to be two strings once again. An object of mass 10 kg is suspended by two different strings by making an angle 30 degrees Here 60 degrees they will give. Find the tensional force T1, T2 within this thing they will ask. At the time how we have to do means at equilibrium position. So mg 10g. So g value generally we will take 10. So therefore weight of this object is 100 newtons. Now resolve this one into two components. If you resolve this T1 into two components, so this is going to be 30 degrees T1 cos 30. So upwards T1 sin 30 degrees. Like the right side. This is going to be 60 degrees. T2 cos 60. Like that T2 sin 60. So T2 cos 60 equal to T1 cos 30. T1 cos 30. So what is cos 60 value? Cos 60 value is 1 by 2. Cos 30 value. Cos 30 value is root 3 by 2. So T2 is equal to root 3 T1. Like that upward forces. T1 sin 30 plus T2 sin 60 equal to here mg, that is going to be 100 newtons. What is sin 30 value? 1 by 2. So sin 60 value root 3 by 2 is equal to 100. So if you write T1 plus root 3 T2 is equal to 2 is LCM. If you send right side 200. This is equation 2. This is equation 1. From these two, we are going to get any one. What is T2? In place of T2, what we can write? So from this T2 root 3 T1 can write here. So T1 plus root 3 in place of T2 we can write root 3 T1 is equal to 200. So root 3 into root 3, 3. So T1 plus 3 T1, 4 T1 is equal to 200. Then T1 is equal to 200 by 4. So T1 is 50 newtons. Once we got T1, what is T2? T2 is going to be root 3 into 50. So 50 root 3 newtons. So like this you can solve very easily. So in vector notation also this type of problems also you can solve very easily by taking this resolution of components and equilibrium position. Okay, I hope you people understood. Thank you.